In example 10.2, it says to give the order of each matrix, and then if we allow each matrix to be called matrix A, then we are supposed to identify the A31 and the A13 entries. So let's start with part A. We have what looks like a 3-row and 3-column matrix. So we will call this a 3x3 matrix. And we need to identify what is located in the A31 position and what's located in the A13 position. So looking at A31, that means I need to go to the 3rd row and look in the 1st column, and where those intersect is the element represented by 7. So A31 is equivalent to 7. And we'll do the same thing for A13. So for A13, we're going to stay in the 1st row, but then we're going to go to the 3rd column, and there's an element there represented by the irrational real number pi. And that's all we're asked to do here. So let's move on to part B. For part B, we have another matrix, and this one has 3 rows with just 1 single column. So this needs to be represented as a 3x1 matrix. So remember, it's the row, then the column. And then we're expected to look for the A31 entry as well as the A13 entries. So looking at A31, that's going to be the 3rd row and the 1st column. So I see that I have the value -4 there. But now I'm supposed to be finding the A13 entry, which means 1st row, 3rd column. There's nothing there. So if your matrix is not large enough to have a particular element, and I'm asking you for that element, then that means that element doesn't exist. So if the element doesn't exist, there's a couple of ways you can write that. You can say A13 does not exist. That's what D and E means, does not exist. Or you can say that it is undefined, because your matrix is not defined to be large enough to have that particular entry. So either way, those would be acceptable ways to represent that A13 doesn't have an answer. There is nothing there for that.